Okay, now let us begin. So today we are going to continue with our same topic of yesterday, that is factors on which resistance of a conductor depends. But you already know this. There is a list of factors on which resistance depends, but actually the main topic of 12.5 is about understanding what is resistivity. So we have gone through at least two sessions now, and in which we have seen in detail how resistivity works and how it is quite different from resistance. And we also know its symbol, that is rho. But today we are going to understand some basic questions which are asked in the exam, so please pay special attention. So in every exam, see, this is part 2 of our same point, so we are not going to start our new point today, it is just a continuation part. So problem is that in every exam there is always a one marker question which is asked. Sometimes it is two marker. They generally ask that what is the use of alloys and why do we use them? That question, and also on insulators. So that typical question we will see today. What is that question and why it is asked? What to write? We'll see that. So question that is asked in the exam is this one, the one which is given at the top. Why use alloys in electrical heating device like electrical iron or toasters? So question will be like this, like the devices, like heating devices, like already know iron, it is used for pressing our clothes, and toasters, it is also one form of heating device, heating electrical device. So they are saying in any of the heating electrical devices, alloys are used. Alloys are used. So they are just asking why to use alloys. So answer is very simple. See, first you have to write down basic thing why we use alloys is alloys do not oxidize, they do not burn. Oxidize means what? Burn. Basically burning reaction is nothing but combination of an element with oxygen. Okay, so even if you use the word burn, it's fine, but more correct word you have to use here is oxidize, because oxidize is nothing but burning part. So alloys do not oxidize, they do not oxidize readily at high temperatures. So these devices are heating devices, correct? So if the temperature increases to well beyond, suppose let's say 500 degrees Celsius or 1000 degrees Celsius, so that element should be able to withstand that temperature. And generally metals have high temperature, but problem is that if you combine them, what is going to happen is they are going to have impurities, and impurities will give you more higher melting points. So alloys, as compared to their metals, do not oxidize easily at higher temperatures. And second reason is that resistivity of alloys is more than metals. This second point we will see later somewhere, that why resistivity is important for alloys in this case. The only point you need to remember here is that alloys have high resistivity and they do not oxidize, that we know, at high temperatures. But this point, the second one, resistivity of alloys is more than the metals. This we'll see somewhere later that why exactly this is needed, because this requires the knowledge of this subtopic. 12.7. In this 12.7, we'll be able to explain that second point, that why exactly resistivity of alloys is we are even considering. For now, you just remember this particular answer to this question, that alloys do not oxidize readily and resistivity of alloys is more than the metals. That's it. Okay. Now, some applications we have to see. One of the what I can say elements which we generally use for particularly making filaments of electric bulbs. So this is a common electric bulb, and you can see there is one filament here. So in the exam, they will ask you this particular filament is made up of which particular conductor. So all you have to say is answer. You already know. You are learning this from 7th grade. That what is the filament made up of? So that filament is made up of tungsten. Okay, so that just remember the application, nothing more. And also remember, whatever we are dealing or whatever I'm teaching you is word to word from NCERT. So nothing is outside the book. Whatever I'm teaching, so please pay special attention. Okay. Now, other materials that will be asked in your examination is about electrical transmission lines. Electrical transmission lines means the wires which carry electricity at your home or surrounding, what I can say, your home. So that means for transmission of electricity, we generally use electric wires. But those electrical wires are made up of two elements only. Either it is made up of copper or either it is made up of aluminium. Because these two elements are very much, what I can say, conductive while we are using them. So hence these metals are used for electrical transmission lines. Now one of the examples which we are going to see is copper. So copper is used. So this is the picture I'm showing you. You must have seen these kind of wires at your home, the right hand side image. So if you cut that particular wire, you will get copper wire inside. So that is the one. and it looks reddish brown. So picture I have also shown you that it looks reddish brown. Now let us focus on how aluminium wire looks. So aluminium wires are available outside your home. You must have seen electric poles, okay, in your colonies, and they must be having one silver lined wires on top of them. So those silver colored wires are nothing but of made up of which element? Aluminium. So inside your home it is made up of copper wire, and outside your home, so that means on the electrical poles, they use aluminium wires. Okay? So just remember that these two are used for electrical transmission lines, nothing more. Okay. Now today we'll see one of the modifications for our resistivity formula. We already know what is the resistivity formula. Resistance equals to rho L by A. So that formula already we know. Resistance R is equals to rho L by A. But today we are going to see some modification inside it. That what modified formula can be used, because this has to be used while solving a numerical. So let us go with it. So we already know what is the formula. Resistance is equals to rho L by A. Now what we are going to do, we are going to modify this particular formula, because we can replace certain values for this A. A is nothing but area. So geometrical formulas for areas you already know from mathematics, from standard 9th and 8th. You already know that various objects, 3D objects, have certain formulas for the areas. So if you substitute area formula here, you can modify this formula. So let us do that. So we will take our wires first, because whatever you are studying, resistivity and everything, it is related to electrical circuits, and electrical circuits will always have electrical wires. Okay? So whenever you are substituting value of area, you have to substitute value of these wires. Okay? Value of these wires, that means the area value should be taken from area of this copper wire. So how to use, so see, focus on this part, this one. So the shape of this particular wire, this copper wire, is circular. So always remember that any of the transmission wires will always be having which shape? Circular shape. So that's why whenever you are replacing formula of area here, you have to use the formula of circle. Because why? Because wires are circular in shape. So whenever you are replacing area formula, you have to replace area of circle. But you know what is area of circle? Pi r square. So we will replace area with pi r square. So let me put that area value is pi r square. Why? Because our wires are circular in shape. So let me put that there. So the formula will become rho L by A, right? That pi r square value I will replace of A. So that formula will become rho L by A value I have substituted. So it is becoming pi r square. So give me response in chat box. Have you understood how we have modified this formula? It is just we have put the value of A because our wires are circular in shape. So that's why we have replaced the value of A as pi r square. Nothing more. Okay, fine. So you do one thing. You write down this particular derivation in your notebook. Okay? I will give you some time. Write down this derivation in your notebook, and we are again going to modify it. Our job is not done yet. This is just one formula, rho L by pi r square. We have to again modify it, because sometimes in the numerical they might give you diameter in place of suppose this is radius, right? R means radius. So sometimes in the question they will give you diameter. Now there are two ways. You can either convert the diameter into radius and then put it in the formula, or you can change the formula, this formula, in such a way that in place of radius there would be diameter. So it's a simple one. Either you change the value of diameter to what I can say radius, or you change the formula which you have in such a way that it will get diameter in the formula. So both the things, both the cases we will see according to your feasibility, like whatever the way you feel is simple, you can use. I have seen students using the same formula rho L by pi r square. They generally have the habit of converting diameter to radius. But some students do not feel it comfortable. They think that it's easy to use diameter in place of radius. So it is your choice. I'm not going to force you for this. Okay. Kritika, what you're asking, wires are cylindrical. It doesn't matter because we are not considering volume. We are considering its area. And when you are considering area, even though they are cylindrical in shape, we are talking about area, only area of a cross section. So we are just taking one section. You don't need to take the complete wire. Just the smaller part. That's it. Okay, so let us try to modify it again because we want to see the formula changed if we can have the value of diameter in place of radius. So how to change the value of radius? So you already know what is the formula for area, pi r square. So what is the value of radius? Diameter is generally 2 times the radius. So if you multiply radius 2 times, you will get diameter. So what I will do, in place of radius, I will replace the value of diameter. So diameter is equal to 2 times radius. So that means radius would be equals to what? Diameter by 2. So that's what I have replaced. So I have replaced diameter by 2. In place of r, I have written d by 2. That square will remain as it is. Now if I square them, it will become pi d square by 4. Okay? So it has become pi d square by 4. Give me response in chat box. Have you understood how, at least till this moment, that how area is getting as pi d square by 4? Okay. So now I'm going to put that value in our regular formula. So let us put that value pi d square by 4 here in this formula, in this one. So that value will become as rho will become same, L is same, and in place of A, we are going to place this one now, pi d square by 4. So pi d square by 4. But you can see this 4 can be shifted to the numerator side. This 4 can be shifted to numerator side. So let me replace that. So this particular formula will become 4 rho L by pi d square. 4 rho L by pi d square. Okay, so write down this derivation in your notebook and then we will continue with our next subpoint. Now, if you're while writing down, just listen to my voice. See, if you're asking me, sir, do students remember this particular formula? So they don't. They generally don't remember this formula because basic formula they already know. Resistance equals to rho L by A. So in the exam, they generally replace the value of A there itself. They never memorize this formula or this one. They generally derive that because it is easy to do. No, it's not that much hard. Everybody knows. Generally you are in 10th standard now, you are learning area of circle since 7th grade, so everybody knows area of circle is pi r square. So you can just replace it. Why to remember the formula? Okay, so you don't need to remember them. All you need to do is derive them in the actual exam. But how to do it is also a technique. So, okay, and I had warned you that some of the students, let's say, have a problem with this particular topic. So this is the problem. Many students face the problem that how come the formula is coming as 4 rho L by pi d square. It becomes difficult for them because they have not paid attention to derivation. Okay, so please write it properly, and once you are done, let me know. Done? Written? Okay. Sure. Now we are going to see today solved numerical. So just pay attention because these problems are already solved in your textbook. So we are not going to write them. Okay? Just pay attention. Okay. First question. How much current will an electric bulb draw from a 220-volt source if the resistance of the bulb filament is 1200 ohm? So there are two questions in the first one. There is A and there is B bit. In the A bit, they are saying what is the current. Okay, so they are asking us to find out the value of current if potential difference is 220 and resistance is 1200 ohm. So we can use Ohm's law. Okay, it's not that much hard. So first we'll solve for A, then we'll go for B. So first, voltage is given as 220, resistance is given as 1200 ohm. What do we need to find? Current. So let me put I is equal to question mark. Current is represented by I. So I is equal to question mark. So V I R. So formula is very simple. V, that is Ohm's law. Okay? Sallu bhai. So that means V is equal to IR. V. So V I R. So V, if you want to know the value of I, so if I need to shift resistance to other side. Here it is in multiplication. After shifting, it will go for division. So I is becoming V by R. So I have shifted that R to other side. Now we already have the values of V and R. Just plug them in this formula, you will get the answer. So it is becoming 220 by 200, 1200. So 220 by 1200, 0, 0 you can cancel. Then you can divide by 2, 2 11s are, 2 6 are, 60s are. So that means the answer, final answer would be 0.18 ampere. Okay? Just you have to use Ohm's law. It was not that much difficult. Fine? Chalo. Let us move for the second one now. In the second one, they are saying find current if potential difference is 220 and resistance is 100 ohm. So in same procedure you follow for case B. For case B, they are saying potential difference is 220, resistance is 100 ohm. We have written both of them. They are asking current. So we said I is equal to question mark. Okay? Now, all we need to do is use Ohm's law again. So let us use V is equal to I into R, but I is equal to V by R. Put the values there, 220 by 100. Okay, so 220 by 100. 0, 0 cut and then it will become 2.2. So answer is final is 2.2 ampere. So give me response in chat box. Have you understood how to solve this? This is a very simple calculation based on Ohm's law. All you need to do is write down the formula and put the values. Okay. Now focus on the second question now. They are saying potential difference between that particular electric heater is 60 volts. So they are saying potential difference between the terminals of electric heater is 60 volt and it draws a current of 4 ampere. So potential difference is given, V is given, I is given. They are asking what current will the heater draw if potential difference is increased to 120. So they are saying initially they have given potential difference and current. Next time they are saying what will be the current if I change potential difference from 60 to 120. So they are asking what is the current if potential difference becomes 60 to 120. So for this case we need to first find out resistance of electric heater. R we need to find out. Okay, because R is constant. So first we need to find out R from this 60 and 4. So let me put that. So we have been given V as 60 and I we have value 4 ampere. So let me put that. From this what we are going to find out resistance, because then that resistance can be used for the second case. Okay? So let us use the formula. So they are asking current at potential difference at 120, correct? So this is question that is asked in the actual this particular numerical. They are saying find current at 120 volt. So find current at 120 volt. So let us use the formula V is equal to I into R. Now V value will take 60 and current value will take 4. 60 and 4. So that will get resistance. So that is a very simple formula. R is equal to V by I. V value is 60. I value is 4. So 60 by 4. And this would be 15 ohm. Okay? Now this resistance I am going to use for the second case. Now second case is same formula will use V is equal to I into R. But instead of using V as 60, we'll use 120 now. 120 because that is the second case. So let me put, we are going to find out current. V we already have. New potential difference is 120. And R value will remain constant for both the cases. So resistance I will use as 15, this 15. So let me put that 120 kahan se aaya? From second case. And this 15 where it has come from? Our resistance, the one which we calculated. So 120 by 15. So 5 3s are 15, 5 2s are, and then 4s are. Let me divide it. So the final answer would be 8 ampere. 15 8s are 120. Okay? So give me response in chat box. Have you understood how to use this? All we did was first calculated resistance from the first case and then we substituted in the second case. Okay. Now focus on this. This is a very important question. They are asking to calculate resistivity. They have given us that the resistance of a metal wire length is 1 meter. So this wire which is given in the question, the length of that wire is 1 meter. And what is the resistance? 26 ohm. Temperature we don't need, but still they have mentioned. So we don't have a formula in which temperature is there. So this temperature we are going to ignore. Then they are saying if the diameter of the wire is 0.33 mm, so diameter is given. Okay? They are asking what will be the resistivity of the particular metal at that temperature. Use table 12.2 to predict the material of the wire. So they are first asking find out resistivity. Then they are saying, please use that table 12.2, which is suppose let's say not to be used for remembering purpose. So they are saying match the value of resistivity and find out which material you have. Okay? So let us not worry about the second part. First, we'll see what is resistivity. You have already have the modified formula of resistivity, in which we have modified the value of A with pi r square. Same formula we'll use in this case because diameter is given, right? So we can change the formula to pi r square or 4 rho L by pi d square. That formula we can use. So length is given as 1 meter. So L is 1 meter. What is R? R is given as 26 ohm. This is not I, this is L. Okay? That is just a font problem, but that is L actually. Now D is 0.3 mm, but we do not use value generally in mm, that is millimeter. We have to convert it into meter. So it will become 0.3 into 10 to the power minus 3 meter. So I have written 0.3 into 10 to the power minus 3 because m is milli. Okay. Now resistance equals to d by 2. Sorry, radius is equals to d by 2. That is radius is half of diameter. So what our new radius will become 0.3 into 0.3 into 10 to the power minus 3, that is diameter, and divided by 2. So our radius is becoming 0.3 into 10 to the power minus 3 divided by 2. Okay. Now our formula is resistance equals to rho L by pi r square. Now you have two options here. You can either use this formula, that is rho L by pi r square, or you can use diameter formula. That is totally your choice. Okay? Even if you use this, it is fine. Even if you use that, the diameter one, still it is fine. So totally your choice. Okay? Okay. Now we are going to plug the values here. So all you need to do is all the values are given. So let me plug those. So we have to find resistivity. So resistivity is equals to R into pi r square divided by L. So I have taken these values of L pi r square to other side and I got this formula. So these values are already given in the question. All these values are pi value we already know. You can take 22 by 7 or 3.14. Totally your choice. Okay? And R, that is radius. So that also we have. And what about L? So L value we also have. So all these things you can put in the actual formula and that will be your answer. So we are not going to calculate right now because there are certain questions in which we have to find resistivity. So let us not calculate. So after suppose putting the values, we will get the final answer as 1.84 into 10 to the power minus 6. Because that calculation part, it's very simple. We are not going to do it right now. So just focus that you just need to plug the values and you will get your answer. So resistivity is coming as how much? 1.84 into 10 to the power minus 6 ohm meter. So give me a response in chat box. At least till now, have you understood how to proceed with this particular question, type of question? How to modify the formula and put the values? Okay. Now, second thing, the question is not done yet. They had said find resistivity. Second question is asked using table 12.2, predict the material of the wire. So we have to also predict what kind of material this is. So you take the value, this one, and you match this particular thing with the actual table which is given in our textbook. So in the exam, if such kind of question is given, this particular table will be provided to you. So don't worry. Now our resistivity coming is as 1.84 into 10 to the power minus 6. This is our answer. Now match this value in our table. This value belongs to which material? You can see that value is 1.84 into 10 to the power minus 6. So it is belonging to which material? Manganese. So whatever the thing which is given in our question is made up of manganese. So answer is very simple. Our answer for this question, predict the material of the wire. So what is the material made up of? Material is made up of manganese. Very simple. Okay? This table will be given in your exam. Don't worry. Okay. Can we proceed? Understood how to just find out the value? Okay? After calculating the answer, you just need to tell the nature. That means to the table. Okay, fine. Now this is another question which is often asked in the exam. They generally see last year you had those kind of questions. You had a lesson called as work and energy, and in sometimes they used to say that what will be the kinetic energy if mass is decreased by 2 or mass is tripled, or suppose let us say velocity is doubled, then what will be the kinetic energy? Same way they will ask you resistance, that what will happen if it is doubled or half. Same question. So focus on this. They are saying a wire is of a given material L, length L. So length of this material is L and area is A. So they are saying the value for the resistance is 4 ohm. Now they are saying if this is the same material, the whatever the material was used in the previous case, if it is the same material, they are saying if the length is decreased by half, okay, it is becoming L by 2, and the area is increased by 2, okay, the area has doubled. They are asking what would be the new resistance. So let us just put the things in the formula. So our first resistance, so resistance of first wire, so formula would be rho L by A. Because L value is given as L, A value is given as A, so we are not going to change anything. But this equals to, this value has been given as what? 4 ohm. The value is given as 4 ohm. So what we'll write down, R1 is equals to rho into L by A is equals to 4 ohm. Okay, so value is becoming 4 ohm, that is given no in the question. Now for second resistance, formula would be same, but problem is that length has been reduced by half, area has been doubled. So I have to substitute, in place of L, I have to put L by 2. And in place of A, I have to put twice of A. Why? Because it has been changed, no, area has been doubled, length has been half. So I need to put those. Now, this particular 2 needs to come down. So it will become L by 4 into A, because this 2 and this 2 will multiply and that will give us 4. So that means rho 2 will become what? Rho 2 will become rho 2. This, resistance 2, R2 will become rho into L by 4A. So rho into L by 4A. That is the modification. But you already know this particular 1 by 4 can be taken out. So if I take this 1 by 4 outside, so inside what is remaining? Rho into L by A, rho LA. So I have separated this 4 outside in the next step. So 1 by 4 rho into L by A. But this value, rho L by A, we already have. Concentrate on R1, rho L by A. So this particular value we already have. That answer is 4. So we will substitute the value of rho L by A as 4. Now that 4 and this 4 will get cancelled and the value will remain as how much? 1. Okay? So that is actually the answer. So that means in this case, the answer would be how much? 1 by 4, and that 4 will get cancelled and the answer would be 1 ohm. Okay. Sorry for that. The answer is written as 4 here, but the answer is 1. Okay? So everybody agrees that resistance 2 will be how much? 1 ohm, because that 1 by 4 and 4 is getting cancelled. Okay. So let me know once you understood this. Okay, all you need to do is put the formula and substitute the values. Okay, fine. Now together we are going to solve blue questions. Okay, so give this particular heading in your notebook: blue in-text questions, page 209. Blue in-text questions, page 209. At least one or two will solve. Okay, I know your another meeting is also there after this, so let us try to solve them quickly. So I hope you are given your heading. Let us start. So our first question is, on what factors does the resistance of a conductor depends? Okay, so that's a very simple question. On what factors does the resistance of a conductor depends? Give me response in chat box. Area, length, Sanskriti, you are right. Area, length, temperature and nature. Yes, what about other students? Only one student is able to give answer. Adhiraj, length, area, temperature and nature, correct. Kritika, length, area, temperature and nature of material, correct. Okay, fine. Okay, so answer is very simple for this question. On what factors does the resistance of conductor depend? Length, area, temperature and nature. Please write down this answer in your notebook. On what factors does the resistance of a conductor depends? Length, area, temperature and nature. And also remember, you have to write down the word area of cross section. Cross section means you have cut that particular wire in a circular way to the base. If you have cut a particular object to its base, it means cross section. That is one of the reasons we had got circular face of that particular wire. Else it would have been cylindrical. So cross section means cut a particular thing to its base. That's why we got circular area. So do one thing, always write down this point as not just area of conductor. You have to write down area of cross section of conductor. Cross section word should be there in your answer. Area of cross section of the conductor. If you just write down area of conductor, half mark will cut, half mark will be deducted for that particular mistake. So you write it completely. Area of cross section of conductor. It means cut a particular object to its base. Okay. Done with writing part. This particular question. What factors does the resistance of conductor depend? Can we move? Can we move to the next question? Students, give me response. Or you are still writing? Length, area, temperature, nature. Okay, fine. Now focus on the second question. They are asking, will current flow easily through a thick wire or thin wire? Will the current flow through, suppose, a thick wire or thin wire of same material when connected with the same source? So we'll do one thing. See, our time is almost up, and okay, I think we can complete this, no issue. Okay, so what do you think? Do you agree that a thick wire, okay, a thick wire, suppose resistance and area are indirectly proportional, right? Area and resistance are indirectly proportional. So can I just say that a thick wire will always have more area? Thick wire का क्या मतलब है? मोटा wire है. मोटा wire मतलब क्या? More area. Thick wire means more area. But more area means what? Less resistance, because area and resistance are indirectly proportional. लेकिन कम resistance अगर है, it means what? More electric current. ठीक है? So that means thick wire will have more area, less resistance, more electric current. थिक वायर मतलब क्या? मोटा मोटा. ठीक है, दैट मींस मोर एरिया, लेस रेजिस्टेंस, मोर इलेक्ट्रिक करंट. गिव मी रिस्पांस इन चैट बॉक्स. हैव यू अंडरस्टूड दैट थिक वायर इज नथिंग बट having more area means less resistance means more electric current? Correct? Okay. And the second one, thin wire. Thin wire example. So thin wire is nothing but very simple. Thin wire, it means less area. Thin wire means less area. If it is less area, it means more resistance. Come area raha more resistance. So more resistance. But if more resistance is there, electric current will be less. Electric current will be less. So out of both the cases, they are asking which of the wires will have more electric current. So obviously which wire will have more electric current? Thick wire. Okay? So write down this answer in your notebook. Write it properly. First write down resistance and area are indirectly proportional. Okay? Then these two. Thick wire means more area, means less resistance, means more electric current. And the second one, vice versa.